Alright, so I had gotten a couple emails and a couple questions over the weekend about this particular problem 3.19. Where we're looking at a piano being pushed to the top of a ramp on a moving van, and then it starts to roll back down. We want to know how much time do the workers have to get to the piano. One of the things that we need to look at here is the fact that we are looking at a ramp, so we are going to have to look at breaking some stuff into pieces. So if I were to go ahead and start looking at that, I have my ramp. It is 22 degrees up off the ground, and we know that the ramp itself at the max height is only 1 meter. Alright, now granted, I do want to note that these are my numbers from the problem. You probably have different numbers than I do. Knowing the height of our ramp, knowing our angle of a ramp, we can actually then find out how long the ramp itself is. Alright, this 1 meter here, this 1 meter here is the opposite side from my angle, and I'm looking for my hypotenuse, alright, which means I am going to be looking at sine. Alright, so sine of theta is equal to opposite over hypotenuse. That means my hypotenuse, when I do my algebra, is equal to my opposite over sine of theta. Alright, and I pull my wonderful handy calculator out. Alright, which, by the way, you do need to make sure that your calculator is in degree mode. When I pull my calculator out and plug everything into my calculator, I get 2.669 meters. Alright, if I were paying attention to sig figs at this point, I would only be able to have the 2.67 or 2.7. However, because this is an intermediate step, I am going to keep as many digits as possible. Right? Now, you might be wondering, well, why did I go through the whole trouble of finding the length of my ramp? Well, I'm going to be using the kinematics equations on this particular problem because I want to know how long do they have to get to the object. I need to know how long is it going to take for the piano to get down the ramp. Right? We are still missing one piece of information at this point. We need to know what's the acceleration. The acceleration of this object is not going to be straight 9.8. Right? Because our object is at an angle, we do need to be looking at this a little bit differently. Alright? So if I look at my object on my ramp, that's my little piano, alright, gravitational acceleration is straight down, but it's only allowed to move parallel to my ramp. Right? As a result, I am setting my axes up so that my y-axis is perpendicular to the surface of the ramp. My x-axis is going to be parallel to the surface of the ramp. Alright? So, because of that, I am going to be looking at my acceleration in the x direction. I'm going to be looking at this piece down here. If you remember when we went through the talks, and there's a long drawn out proof for this particular fact, the angle up here, alright, is going to be equal to the angle of my ramp. I'm going to make that a little bit clearer. The angle up here is going to be equal to the angle of my ramp. Alright, because of that, I'm looking at my opposite side again. So I am looking at the fact that sine of theta is equal to my opposite over my hypotenuse. I'm looking for the opposite side, so my opposite is equal to my hypotenuse times the sine of theta. Alright? My hypotenuse in this case is the value of g, right, which we know is 9.8 meters per second squared. So I'm going to look at 9.8 times sine of 22 degrees. My acceleration in the x direction as a result is 3.6 .671 meters per second squared. Alright, I have my acceleration, I have the total distance that this is going, and I know what my initial velocity is, right? They leave it at the top of the ramp, so we know that our initial velocity is 0 meters per second. Alright, so we can go ahead and pull our very popular kinematic equation. XF is equal to XI plus VIT plus 1/2 AT squared. Right? XI we can go ahead and assume is 0. XF is the length of our ramp. VI we know is 0, right? Because it's starting from rest. A is the A of x we just found, and we're solving for t. So we'll go ahead and zero our stuff out that we need to. Right. XF is equal to 1/2 AT squared, with the whole process of algebra going through. For this particular bit, I do get the fact that t is equal to the square root of 2xf divided by a. Alright, I'm going to go ahead and plug and chug from here. 2 times 2.669 meters divided by 3.671 meters per second squared. And this does give me I have a typo going on over here. And I get, they have 1.21 seconds to catch the piano.